Hi, okay. I want to talk a little bit, before we get into the deep details here, about how we deal with numerical error in Orthohack. Because remember, Orthohack doesn't take an algorithm and then symbolically optimize it into a better algorithm. It takes simply a numerical image of orthobasis vectors, and it derives an algorithm from them. So clearly we're going to have some numerical error, right? Because when you generate those orthobasis vectors, you're going to be rounding off and dropping bits here and there. And you may have two terms ultimately that are supposed to be equal but are slightly different. And how do we deal with that in an intelligent way? One way is we have the precision zero limit control. This is a dial you can turn. And basically what it does is it prevents us from wasting a lot of time on terms that don't add anything to the transform for realistic purposes. So here we have an orthobasis vector, and it has a bunch of sample points above and below 0. And this particular point is 5 times 10 to the minus 17th. So this one, if let's say my precision zero limit is 10 to the minus 16th, then this guy is going to get flushed to 0. If it's 10 to the minus 19th, it's not. Okay, so that can actually end up saving quite a bit of time and space. The other thing is the precision ratio limit. And this is really how we get common terms to combine when actually all the terms are slightly different. So in this same example, we have a bunch of numbers that are very close to 2.14. One's a little bit above it, one's a little bit below it. And what this says is that if I take a list of numbers, and it's usually a sorted list, so it makes things simple, but if I take a list of numbers, and actually it is a sorted list, I'm sorry, and all of the rest of the numbers, it's sorted by magnitude, right? So all the numbers are positive, and if I take the first number in that list, and that's within a certain percentage of the slightly larger numbers that follow, then all of those numbers are deemed to be equal, which means that we take their average and we replace all of them with that average. So then all of these would become 2.14, which would allow us to combine everything and probably save some time. So not that we necessarily combine different samples, I didn't mean that, but where we are allowed to combine equal terms, we will then do that. And you could argue that we should combine these, instead of using averages, we should use geometric means or something, depending on the circumstances. My opinion is, frankly, when they're so close, it actually doesn't matter much, but that's a potential enhancement if it really mattered. Okay, that's it for this video. I'll make another one.